Hello, everybody. Welcome to my session on additive manufacturing processes. Myself, Dr. Kode Jaya Prakash, working as Senior Assistant Professor from Department of Mechanical Engineering at VNR VJEC. In a previous session, I discussed about this introduction of additive manufacturing processes. Means that what are the different types of additive manufacturing and what are the materials which are going to suit for the process, and also what is the classification of additive manufacturing. So that so each and everything I had discussed in the previous session. So now we are going to discuss about what are the processes that are involved in additive manufacturing process. By it is going to dependent upon the classification whatever I had discussed in the previous session. Okay, now I'm going to discuss about each and every process and its applications and a brief video of it. So now first and foremost thing we are going to see is SLA, stereolithography. So as we had discussed about this SLA process, this comes under liquid based AM process, and also this other name for SLA is also called as VAT photopolymerization, right? So this means that the raw material is in the form of a photopolymer liquid. So this photopolymer liquid, so when it is exposed to UV laser or UV light or gamma rays or X-rays, an exothermic chain reaction is going to happen, and it in turns become solidified from liquid stage to it becomes solid stage. So this is the technique which is going to be used by the SLA process. So as you can see here, what are the brief highlights of SLA process? So this is the first additive manufacturing technique which is developed by Chuck Hull. So that Chuck Hull is the name of the person who has developed this additive manufacturing techniques. Okay, so among all the techniques, so SLA process is the first and foremost thing which is invented. So next, coming to that, it is quite inexpensive when compared to other techniques, and also liquid photopolymer is going to be used, and after this additive manufacturing of the part is going to be done, so then the part has to be taken outside and it should be cured in the oven, and then after drying, then the part has to be taken outside, and support structures are entirely it is required to optimize the supports is required, and design of the supports are quite entirely required, right? So this process is completely simple, and we can able to work this entire process around the clock. This is the specialty of this SLA process. Now coming to the case of process parameters. So each layer thickness is 0.076 mm to 0.550 mm, and in case of inches it is 0.003 inches to 0.020 inches thick, and laser speeds is going to be typically from 500 to 2500 mm per second. And coming to the case of this working principle, so it is now, so as you can see this working principle here, as you can see this photopolymer liquid resin, so this VAT photopolymer liquid is going to be filled in the entire entire box, and then the elevator platform is going to be sent to the downwards. So here an optical scanning system which is going to be used, then it is going to be used by the laser, UV laser here it is going to be used. An optical scanning system is going to be focused on the surface of the photopolymer liquid, and here as per the STL file instructions, the photopolymer liquid is going to be cured by the UV laser. So as soon as it is going to be cured by the UV laser, a recoater blade, as you can see here in figure, in this recoater blade is going to be supply so equal amount of liquid resin on the previous layer which is going to be cured at earlier, and again the photopolymer liquid is going to be cured by the UV laser, and the elevator platform moves downwards. So this process is going to be continued till the completion of all the layers, and afterwards this the elevator platform is going to be taken upwards, and then the part is going to be taken outside and it is going to be cured in the oven. So this is the working process of the SLA process. As you can see here in this figure, you can see the platform, so elevator platform. So because this elevator platform is going to be completely immersed inside the photopolymer liquid. After finishing off all the layers, then it is going to be taken outside, and then the part is going to be removed. So, and here you can see here what are this photopolymers, how these photopolymer liquids are going to work out. So as I told you earlier, it is going to be work with this photopolymerization. So means that an exothermic chain reaction is going to be happen. So when it's exposed to X-rays and UV rays. So here as this chemical reaction is going to be taken, and monomers and photomers, and is going to be happen in the excited state. So this excited state is going to be leads to the chain reaction. So because of the chain reaction is going to happen, this liquid enters become into solid stage. So next, coming to the case of composition of the liquids, can have the binders. So this binders, mostly it is going to consist of in the range of 50 to 80% of the total weight. It's a chemically reactive molecules that gives its final solid its mechanical and other properties. And most of these binders are going to be used as acrylates, epoxies, and urethanes. And coming to the case of monomers, so monomers is an atom or small molecule that is going to be bind chemically to the other monomers to form a polymer. So here this monomers may typically constitute of 10 to 40% of photopolymers. And coming to the case of photoinitiators, this photoinitiators is going to be split into two to more parts when the light is going to be exposed, when the liquid is going to be exposed. And these photoinitiators are only sensitive to specific wavelengths of the light, whether it is UV laser or UV light. It depends upon the type of liquid, whatever we are going to use here. And so this is the chain reaction is going to happen. As you can see here, photoinitiator P1 and monomer M is going to be formed here. In the second stage, the photoinitiator and is going to excited stage, and free radical generation is going to happen, and followed by chain initiation and chain propagation, and followed by chain termination. So this in turn forms a photopolymerization. This is very important, especially in the liquid-based AM process. So as you can see here, I told you Chuck Hull is a key person who has invented this SLA in the mid 1980s, which is founded by 3D Systems. So this 3D Systems is the famous company which is going to be this evolved in the US based. And right now this 3D Systems and Sony are going to be are the manufacturers of this SLA process. And you can see this maximum build size 1500 mm by 750 by 550 mm, that is LWH. And resolution in the case of spot dependent, and resolution in Z 0.004 inches, and cost is too high. And available materials, it is all in the form of photopolymer liquids, is a thermoset polymers, which is going to be act as a photosensitive resins. Coming to the case of applications, you can see the prototypes for demonstrational purposes, and patterns for investment casting and sand casting, and also going to be used for making of the tools for the tooling design and the fixes. And advantages of this process, as I told you this earlier, this is a round the clock operation, and good user support, and good accuracy, and good surface finish. When you compare with all AM process, it is going to produce a good surface finish. And coming to the case of drawbacks, so support structures is quite it is a tedious task to remove the supports, because additional post processing is required, and much more care is going to be taken to remove this support materials. And now you can see this brief video of this SLA process, as you can see here. So how this a short video of this SLA process. And first this CAD model is going to be done, and later it is going to be converted into .stl. These are industrial printers. So it is going to have the big volumes, as you can see here. So it is a elevator platform. So that is a recorder blade. So whatever I told you earlier. So that laser is going to, optical scanning system is going to trace the initial first layer. So after this tracing of the first layer is going to be done, then the recorder blade is going to supply evenly this photopolymer liquid on the previous layer which is going to be cured. So this process is going to be repeated till the completion of all the layers. And then it is good, the elevator platform is going to be moved upwards, and then the part is going to be taken outside along with the supports, and additional post processing is required to remove the supports, as you can see here. So you can see these are the support structures. So optimization of supports is very, very important for SLA process, because to scan the because the laser is going to scan in the inclination. So that is the reason why everything we need to orient the STL file, especially in angular orientations, because for the easier scanning of the laser. So it's not like fused deposition melting, which is going to be done completely on the flat surface. You can see after removing the supports, you can see the complex profiles and then additional post processing. So you can see this, yeah, you can see the accuracy of the part. You can see the finish of the part. SLA is going to produce a much amount of parts, much amount of accuracy for all the parts. As you can see here, this is additional post processing. There's a priming and painting to make the surface a shiny finish. Yeah, you can see this complex contour profiles. So whereas it is not possible by using subtractive manufacturing, that is why this additive manufacturing is going to play a key role for this process. And next, after this SLA process, now we are going to discuss about fused deposition melting. So this fused deposition melting comes under material extrusion. So it comes under metal extrusion. So it is supposed to be called as metal extrusion, but in classification, people used to call it as solid-based AM process. But the exact word is metal extrusion. The metal is in the form of a wire, is a form of a filament. Wire or a filament. So here I can use this filament or wire is going to be taken, and it is going to be supplied to the extruder here. This is called as extruder. So this extruder is having the stepper motors. So this stepper motors is going to pull this wire filament towards inside it, and as per the instructions of the STL file, as per the G codes, then it is going to move in X, Y, and Z directions to lay up the part. So as soon as the first layer is going to be done, then the elevator platform is going to move downwards, right? So then it is going to be again, this extruder is going to deposit the previous material, which is going to be done on the previous layer. So like this, for each and every layer, the elevator platform is going to move downwards, and then after finishing of all the layers, then the elevator platform is going to be moved downwards, and then the part is going to be taken outside. So this is the working principle of fused deposition melting. So here the metal is going to be fused and get deposited. So that is why it is called as fused deposition melting. So here this X, Y, and Z-axis, because so a 3D printing technique, it is nothing but it is a Cartesian coordinate system. X, Y, and Z direction is going to move upwards. So for each and every layer, the build platform is going to move downwards, and then later on, after finishing of all the layers, the elevator platform moves downwards, and then part is going to be taken outside. This is a working principle of FDM. And coming to the case of FDM, is going to invented in early 1990s. Which is going to be done by the Stratasys company in 1999, going to be done for the market, and current market leaders are Stratasys only. And then you can see here maximum build size is 20 by 20 by 20, and resolution XY direction is plus or minus 0.002 inches to 0.005 inches, and speed is somewhat slow when you compare with all other process, and cost is medium, and materials is all thermoplastics like ABS, PLA, TPU, and nylon. All the sort of materials, also thermoplastic materials are going to be used. And coming to the case of applications, that is a conceptual models, that is only for demo type models. Only for demo type models is going to be used, but only limited functional models is going to be taken, especially for rapid tooling. For rapid tooling, so making of the patterns, this is going to be used, but where accuracy is not a big concern. In that areas, this sort of FDM is going to be used, but mostly it is going to be used for functional for demo models. And coming to the case of advantages, is more economical and enables of multiple colors, and a wide range of materials is going to be possible. And coming to the case of drawbacks, unpredictable shrinkage. So this shrinkage of because of this warping and the shrinkage defects, this FDM is going to be the utmost care should be taken, especially for the making of the build platform temperatures, and also usage of additional glues, etc., to avoid this warping sort of defects and shrinkage defects. And you can see this do it by do it by yourself FDM means that you can able to assemble the parts, and you can able to develop your own printer. That is called as do it by yourself FDM, rapid prototyping techniques. So you can see here these are small models you can able to make, the demo models, and it is the printer is going to occupy it's very compatible, and very less space is going to occupy. You can able to work with different colors. Okay, and you can see there's a small video of FDM. And in this video, you can see the working principle and how that uh, filament is going to be drawn by the extruder, and how it is going to be deposited on layer by layer. As you can see, these are called as industrial FDM printers. See how this material is going to be laid up. The extruder is going to be depositing on the elevator platform. It's called as elevator platform. As soon as the each and every layer it is going to be deposited, is going to move downwards. So how these layers are going to be built? This entire magic of AM process is going to be done using the CAD files. So this is a cartridge which is going to be filled by the this solid wire filament. And two filaments is going to be shown. One can be used for build and other can be used for support material. That extruder is going to be pull it and is going to be drawn the filament inside. You can see the support material is going to build material, and this is how it is going to lay up the. This is going to fuse and going to deposit on the surface of the platform. That is why it is called as fused deposition melting, or otherwise it can also be called as fused filament fabrication, FFF. You can see the support structures and the build material. And this support structures is not that much difficult to remove when compared with SLA process. We can able to, these are breakable supports, so easily you can able to remove the supports. And additional post-processing techniques like sanding, polishing, etc. is going to be used to make the surface finish. You can see the support structures, right? This is the working of the fused deposition melting. And this is a fused deposition melting technique is in a affordable cost. We can able to procure it. Whereas with the other printers is not not that much easy to procure it, because still their patents are yet to be expired, because this FDM only, because of the expiry of the patents, we are in a position to procure that machines. So this is how this FDM is going to be worked out. And next technique comes under laminated object manufacturing. This laminated object manufacturing comes under sheet-based AM process. Means that raw material is in the form of a sheets. So you can see here this take-up roll and supply roll. This supply roll is going to be, and this sheet is going to be self-adhesive, because each and every layer of the sheet is going to be self-adhesive, and later on the part is going to be taken outside. You can see the supply roll and take-up roll, and here you can see that CO2 laser, the type of laser we're going to use, CO2 laser. The CO2 laser is going to be drawn the first layer is going to be cut the entire sheet. So, and remaining portion wherever the laser is not cutting, so that portion is going to be sliced in the series of squares. So that slicing of the portion which is going to be which is not cured by the laser, so it is going to be done by the series of squares. That series of squares, how it is going to be done, the other name for it is called as a dicing. So those dice is going to act as a supports for the part which is going to be built. The extra portion which is going to be not cured by the laser, it is going to be sliced by the laser. That is called as a dicing. So this also the dicing, and also it is also called as a cross hatches. So these cross hatches are going to be act as a support material. So that is the reason why for laminated object manufacturing additional supports are not required, just like FDM and SLA process. So here support structures is not required. As you can see this, and after the each and every layer is going to be cured by the CO2 laser, the part is going to be completely enclosed in a box, and later on we need to use the separate hand tools to remove that box and take the part outside. And when you compare with other process, this metal usage is somewhat more. But here only the thing is that the process is completely fast, and additional post processing is going to be very tedious task, because if utmost care is not taken for the post processing, the part may subjected to damage. So this is the main drawback for laminate object manufacturing. As you can see, this laminate object manufacturing is going to be developed by the Helicis of Torrance in California in the 1990s, and LOM equipment is going to be used for this for the decorative models and making of simple patterns where accuracy is not a constraint. And you can see this maximum build size for 40 inches by 40 inch by 20 inch, and resolution is plus or minus 0.004, and speed is medium, and available materials are, so all these materials are going to available in the form of plastic, in the form of a sheet based. So paper, plastic and sheets. Okay, and key applications are going to be used for pattern making and decorative objects, form, fit and function. Rapid tooling is going to be used for making of the small patterns. And advantages of this are relatively high speed process and low cost. That's a really, because all the materials we are going to use are readily available materials, and part can be used immediately after the process. No additional support structure, because I told you that the cross hatches or dicing are going to be act like supports. So coming to the case of drawbacks, removal of the scrap is more tedious. That the Z resolution is not as high. So when you compare with other technologies, and limited metal set, and also precise power adjustment is required. So this post processing is one more tedious task to remove the part outside. Just have a look at the video of this. Laminate object manufacturing. So this is the entire setup of the laminate object manufacturing. So the CO2 laser is going to be drawn the shape, whatever it is required as per STL instructions, whatever you are going to give it to the CO2 scanning system. So you can see the part which is required is going to be taken, is going to be, and then a remaining part which is not going to be cured by the laser is going to be done with the cross hatches. You can see that small squares you can see here. The part which is required is, you can see that square symbol and the round symbol. Apart from that square and round symbol, the remaining part is going to be done with series of squares. That is called as dicing. Yeah, you can see that dicing. So this dicing is going to be done layer by layer. Yeah, the cross hatch, and then again the second sheet is going to be that is, I told you, self adhesive sheets. The after curing is going to be done. The second layer of the sheet is going to be support is going to be kept on the previous layer, and then again the other layer is going to be cut by the CO2 laser. So this process is going to be continuous, and it is going to form a quite enclosed box. And in that enclosed box, we need to use the different hand tools to remove that cross hatches, and we were supposed to take the product outside. As you can see, so here, so this cross hatches is going to be taken outside. The entire thing is going to be enclosed in a box. So that removal of the cross hatches is a very tedious task. So where you can see this, so this is a part which is required. Like this LOM process is going to be work. Thanks a lot for seeing this valuable session. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.